In this example, we would like to find the zeros of this function and state their multiplicities. So I'll first set f of x equal to 0, and then I want to solve the right-hand side, if I can, by factoring and finding x. Alright, since I have this equal to 0, and we have 4 terms on the right-hand side, I'm going to try to factor by grouping. Grouping means that you group the first 2 terms together. You will always put a plus sign next, and then you will group the last 2 terms together along with their signs. From the first group, notice that the first term is negative, so I'm actually going to factor out a negative from that group, but I'll also have an x squared in common. So I'll factor out negative x squared. I'm then left with positive x and minus 2. From the second group, the first term is positive, so I'll factor a positive out, and then we have a 4 that is shared, and so I'm left with x minus 2. Our goal in mind is to try to make sure that these two match. If they do, you write that factor once in the front, and then you'd multiply by what was left over, the negative x squared plus 4. Now, on this one, we have a special situation with the group in the second set of parentheses. And the situation is the first term there is negative. So what I'm actually going to do is I'm going to factor a negative 1 only out of that particular group, and I'm going to place it in the front of everything so that I don't lose it later on. So the negative 1 is going to come out, the x minus 2 is going to remain the same because I'm not factoring anything out of that group, but then over here I would change the signs on both of these terms. So it would be a positive x squared and a minus 4 since I factored that negative 1 out. Now the reason that I did that is so that I could factor that second group. With it as it was before, it makes it awkward to factor. But with the negative distributed or factored out, I can now see that this is actually a difference of squares and write it as x plus 2 and x minus 2. Now when you get to this stage, if there are any factors that are repeated, I'd like you to write them as exponential. So in other words, x minus 2 and x minus 2 are repeated, so write x minus 2 to the second. And then x plus 2 has an understood exponent of 1. To determine the zeros, the power doesn't make a difference. So me saying that I have a factor of x minus 2, I don't care if the power on it is squared or to the 100th. The actual zero of this particular factor would be the number that would make that factor 0, which in this case would be 2. This 0 would be x is negative 2. Okay, now this problem asked me to state the multiplicity of each. So this one has a multiplicity of 2 because of the power up here. This one has a multiplicity of 1 because of the power there. If I were to graph this function, the multiplicity of 2 being an even number would mean that my graph would turn around at that particular 0. On the second piece, the multiplicity being odd, 1, means that my graph would actually pass through that number negative 2.